All right. So, what are the problems that we are trying to solve here? I don't think it's any secret that the utility industry is a little behind on implementing modern technologies, particularly as it relates to data and analysis. But what we're going to propose today is that now the time to start making this transition, both to meet today's challenges as well as the challenges for the future. Couple of things going on in our industry that make this a very critical time for us. A lot of utilities are undergoing large-scale replacement programs as well as expansion programs. The infrastructure, both in Europe and the US, is getting to the end of life, and the need to replace those assets is growing every day to improve public safety and system reliability. With all of that construction activity goes with the increasing threat of excavation damage. For underground assets, it has always been a threat, but as more construction activity is increasing, then it just increases the threat of excavation damage. And then what we're going to propose today is that current data collection practices are not sufficient to meet the challenges of the future. We are going to be, whether you're a natural gas operator, considering the impact of hydrogen on your infrastructure, the need for data to support that transition, and for electric utilities, the ability to manage the smart grid of the future, distributed energy, and all the challenges that are going to come along with that. So again, high quality construction data is useful today for a number of reasons, and we'll get into some of that in a little bit. But it's also preparing us for the future, where we're going to have very data hungry systems, and we're going to need to do analysis to support the upgrade of our infrastructure as we move towards decarbonization. All right, so current practices. What we're going to look at here is what a typical utility, what their practices look like for data collection throughout the construction process. So if we start all the way back at the planning and engineering phase, there's a number of tasks that have to be completed in order to prepare for a new construction project. And here we're talking about the engineering and the budgeting. You might use compatible units as part of that process to select the materials and develop the budgets for the projects, preparatory work for permits and getting the right-of-way approval from the regulatory agencies. So there's a bunch of prep work that needs to be done. And most utilities have systems in place to support those workflows. But for the most part, they're pretty isolated, and they're done by individuals who have specific roles and specific tools to do that. But getting that data out to the field, it typically involves printing papers and putting them into folders and giving them to field crews. So it remains a very isolated and siloed workflow. And then, of course, the data associated with that also remains very isolated. So the field crews eventually get the information that they need, but it is in a paper format, or even if you're using technology, it's in a fairly siloed technology stack where the data doesn't the data can't be leveraged, and it's not integrated into a single digital thread. So then the construction crews begin their work out in the field, and this is where the real heart of the process is, because this is where you're collecting all of the data about the assets and the way that they were installed. And this is typically done using a combination of paper, sketches, sketching out what assets were installed and what materials were used, maybe using Excel or some one-off application to capture information about the materials that were used, then the labor and all the equipment that was also used. So it's usually a combination of paper, maybe some Excel, even Microsoft Word, and then some one-off applications. So again, we're collecting the data and it eventually gets collected, but it's in siloed systems that are not integrated as part of a single digital thread. So then what goes back to the office? Another paper closing package that has all this data. And then it's the responsibility of someone in the back office to manually review all this data, to read a bunch of handwriting, notes sketched on paper, and to decipher it, and to manually reconcile all of the field collected data and manually enter the data into the systems of record. And we're talking about GIS for the mapping system and asset management systems for accounting and life cycle analysis. And all that information is manually uploaded into these systems. So obviously another opportunity for error to have the information manually read off of the forms and manually updated into the systems of record. So maybe I'll take a pause here to open it up to some of the attendees, just to see if this resonates or if this represents what a typical construction workflow looks like.
We will be happy to have someone speak. So if you would like to speak, please just raise your hand, and then I will be able to turn you into participants. Or you can use the Q&A. Hey, I see you, Joe.
Thanks, Emily.
Yeah.
Sure.
So it looks like we have Eva and Rebecca here who are outside of the organization. Maybe they have any questions. Otherwise, we could move forward. It's a good thing that the presentation is also going to be recorded. So.
Okay, we can keep going.
Move on. Yes.
Okay, so we just went over what the current practices are, and now what we're going to propose is the concept of a digital thread that links together all phases of construction to create higher quality data, as well as a process that's more automated and efficient from a labor, cost, and time perspective. So you're still going to do all your upfront planning in a similar way, but where we can start to create this concept of the digital thread is when we combine the data from all of those different systems in the planning phase into a single digital job packet. So we can get the graphic work design from the design tool. We can get the compatible units with the budget, labor, and material information. We can get detailed material information from a company catalog. You can even create a bill of materials for the individual project. So there's a very detailed list of the quantity and attributes of the materials that are supposed to be delivered to the job site. And then, of course, all of your work order data about the location of the job and who's assigned to it, what the qualifications are. So all of that data gets put into a single digital job packet and attached to the work order, and then that's what gets delivered out to the field. So now the field crew has a digital job packet that has all of the information about the engineering procedures, the permits, the materials, and the instructions for that job. Now in the fields, now we're going to be using digital technology to capture all of the construction data, particularly around the as-built data. And as-built data is usually the thing that breaks the digital thread. Most companies are not capturing as-built data digitally. They're relying on sketches and hand notes. And so this is really where a breakdown in the digital workflow typically happens. But what we're proposing is that utilities would use technologies such as GPS and barcode scanning to automate the capture of digital as-built data and then add that to the digital thread. I've got an example that I'll walk through to demonstrate this concept a little bit more, but you're eliminating any of the manual data collection for the as-built and capturing everything digitally. It also allows you to not just collect the data digitally, but also to run real-time validations. So now you can compare what you planned versus what was actually done in real time. And if there's any discrepancies, that can be flagged in real time in the field so that there's an opportunity to correct it before it gets delivered to the back office. So those types of validations are eventually done with the paper process. It's just that they could be done weeks after the project is complete. And then it's a hassle to go back and try and fix it when the assets have already been buried and maybe they're even in service already. So obviously capturing that or performing that validation as close as possible to the construction workflow is what is going to allow us to mitigate those threats in real time. So all the construction data is now captured digitally. So now instead of a paper packet going back to the office, we have a digital closing package, a single database that continues this digital thread that has all of the construction and as-built data that is then linked to all of the engineering and planning data. And now we can have a really automated closing process where the reconciliations are performed automatically and data can be entered into the system of record seamlessly without someone having to manually enter the data.
Alicia?
Yes.
Can I interrupt? We have two very good questions. First one is from Rebecca Payne, and she's asking if we're working with other GDNs or DNOs and we have any case studies. So, of course, Rebecca, I can share with you our case studies, or you can even go to our virtual booth and see all the case studies over there. And the second question is, and Alicia, if you want to answer if we're working with other GDNs or DNOs. The second question is, what is the difference about our system compared to other providers?
Mm-hmm. So yeah, we actually have a couple of case studies in here. I'll make sure that we leave time to get to those. And on the second question about what are some things that are different about our system, yeah, let me jump to a slide that has a little bit more information about that. So right before I do that, just talk about the general value proposition here. So why would you want to use a digital thread? So it increases data quality. You're not having people manually type information in. It's as much as possible, data is brought from the previous step into the next step, and then we're adding data from that phase, hopefully through sensors and digital techniques, and we're adding to that digital thread. Also decreases risk because you're bringing the knowledge from one step to the next, and you are allowing the next phase of the construction plan to have all the knowledge from the previous step. So, for example, and I'll use this as a way to highlight one of the differences between our system and perhaps other technology providers, is that we're able to bring information from the planning phase into the field to allow the field crews to automatically validate materials. I think it's a pretty unique attribute of our system, where we have a direct link to the material catalog and all of the engineering information, and we can create a project-specific bill of materials. And then that information is used to validate the materials in real time. That's one example of some of the unique functionality of our system. Maybe another unique component is our ability to use barcode scanning to capture material attribute information. So most assets have barcodes on them, whether it's a gas pipe or a transformer. Most assets have barcodes on them that have information like serial numbers, size, wall thickness. And by scanning that barcode, you can automate the process of capturing that information and updating the digital thread. Okay, so what I was going to do here is walk through an example of what the digital thread would look like, and I'm using a natural gas pipe as the example here. I'll go through this kind of quickly to make sure that we have time to get to the case studies and examples at the end. So here we're starting our construction process. This is for, say, a large pipeline project. And what I've done here on the right-hand side is just create a shell example template of what the digital thread would look like. This is not complete. There would have to be a lot more data that would be collected, but just for purposes of this, these are the data elements that we'll be working with. So in the planning and engineering phase, you've got your engineer that's using, say, compatible units and the material catalog to identify the materials that are required for this job and what all their attributes are, including cost information and engineering procedures, such as the test that it needs to be run at. So all that information is populated in the plan section. Then when we purchase the asset and receive it, now we've got information about the actual asset that was received. And in this case, we'll now know all the material properties about it. So we can use that to start populating the actual side. And here's where we can start running our initial validations to say, we ordered a pipe that had a certain wall thickness. We can validate that what we received actually had that wall thickness. Then you bring it out to the field and you start doing things to it, starting the construction process, whether this is splicing or welding. You need to prepare the asset to be installed, and that's usually a very critical task. And you want to capture information about who did it, what procedures they used, what were the steps that they went through to perform this work. And so for here, the example is the weld. And here we can capture information about who did the weld, what materials they used, what procedures they followed. And then we can perform that real-time validation to ensure that they did the appropriate work in the field. And then we create a traceable record for it and adding that information to the digital thread for the asset. So you can see as we're doing work to the asset, we're capturing data about it and then using that to populate the digital thread. All right, now we're ready to install the asset and capture the as-built data. So we're laying it into the trench. Here's where we can do our barcode scanning to capture additional attribute information. And this is, we can get very detailed, even including serial number, lot number, heat number, the production date, the manufacturer. All of that can be captured from a simple barcode scan and used to automate the process of adding that data to the digital thread. And this is another really important innovation here, both for our system, but just as the industry as a whole, is this concept of using barcodes to automate the as-building process. You can put a lot of really high quality data into a barcode, and it eliminates the need for the field crews to manually enter the data. So the barcode scanning plus GPS, the high accuracy GPS to create the spatial locations, those are the things that have allowed this workflow to be possible. Because if you're asking the field crews to enter a bunch of information manually into a software tool in the field, it's not really feasible. You know, they've got gloves on, they've got their shovel, and then if they've got to sit there and click a bunch of things, it's just not feasible. But with the innovation of the barcode scanning and the GPS, it's literally a couple of button clicks. And now it is feasible for them to capture this high fidelity construction data using a digital as-built. Last step is to perform the test. In this case, it would be a pressure test. Capture that information, again, doing that real-time validation against the engineering design to say, all right, this was supposed to be run at a certain pressure for a certain amount of time. and then validating that that is what is actually done in the fields. And now that we have all this information digitally, now we can automate the reconciliation process and say we were supposed to install 52 valves or 17 transformers and 18 poles, but here's what we actually did, because you have a very detailed digital record of what was actually done, and you can automate that reconciliation process. Some of the utilities that are using our system report that this is one of the most beneficial parts of the system because it automates something that was typically done very manually, where you had Excel sheets or handwritten notes that they had to compare against the budgeted information, and it's a very long and tedious process. And technology like this completely automates that process and removes the need for anyone in the back office to have to manually do that. And then finally, but most importantly, we're updating the system of record. So you've got this digital thread of everything that was done in the construction process, full digital twin of your asset, and now we need to update GIS and the asset management system. So but you've got one single database, your digital thread, and that has all the data that you need. And some of that data needs to go to GIS, some of it would need to go to the asset management system, but all of that is automatically done. All right, so a couple of case studies here. This is one where an operator, the original reason for implementing the technology was because they wanted to ensure regulatory compliance. They had an extremely large replacement program. They were replacing hundreds of kilometers of pipe every year, and they wanted a digital solution to eliminate all of the paper. So what they implemented our solution both in the field and in the office. We integrated with their Maximo work management system so that work orders that come to the mobile application together with a bill of materials. And they capture the information in the field. And with this automated reconciliation process on the back, they were able to reduce the amount of time it takes to get data into, to close out the projects. It was a 90% reduction in the amount of time it takes to reconcile materials. And then they also saw a dramatic reduction in materials that were unaccounted for in the fields. Second case study is with an electric and gas operator. Similar situation where they wanted a solution to capture high fidelity data that was traceable, verifiable, and complete for regulatory compliance. But once they implemented it, they saw that they could create a lot of other automation throughout the process. So they implemented a similar solution, also integrated with Maximo work orders in the project bill of materials for that digital thread. And they're in the process of also adding compatible units to the digital thread so that now we're able to bring through budget information. Right now it's just materials, but now adding the CU component to it is how we can bring the budget information. So now they're going to be able to reconcile both materials and budgets at the end of the project. One of the big benefits for them was the real-time validation of materials. They were having issues with improper materials being installed, but now with this technology, we automatically validate that the correct materials are installed and add all of that, all of the material properties for the assets to the digital thread. They also saw a big increase in standardization. They have a lot of contractors. I think this company has 50-something contractors that perform work for them, and everyone had a slightly different way of doing things. But technology does have a forcing function that forces standardization across the organization, and that concept even flows down to the contractors. And when you implement technology, it is a mechanism for you to enforce standardization of data collection for both in-house and contract crews.
Alicia, we have 40 seconds left, so last few words.
That's it. We can go to questions. if there's any more.
Okay, let me see. How can your technology support the transition to hydrogens and retrofitting of the existing gas networks? I don't think we have enough time to answer that in 20 seconds, but please feel free to reach out to any of us, either Joe, Alicia, myself, or the rest of the team. Thank you very much for joining us. That's it.